Today we are going to learn about the intersection of lines and parabolas. The National 5 essential skills are finding the discriminant and using simultaneous equations, specifically substitution. Intersection of lines and parabolas. To determine how many times a line intersects a parabola, we must substitute the equation of the line into the equation of the parabola. We can then use the discriminant or factorisation to find the number of points of intersection. Remember from National 5 that if your discriminant is greater than 0, the line and the curve will intersect twice. We have real roots. If the discriminant is equal to 0, we have equal roots and the line and the curve intersect once, and therefore the line is a tangent to the curve. And if your discriminant is less than 0, there are no real roots, the line and the curve do not intersect. Key steps. First step is to substitute the straight line equation into the curve's equation. Step 2, rearrange and equate to 0. Step 3, use the discriminant to find the number of points of intersection. And step 4, if you are asked, find the coordinates of the point of intersection. Example 1. Show that the line y equals 5x minus 2 is a tangent to the parabola y equals 2x squared plus x and find the point of contact. So to prove that a line is a tangent, we should use the fact that the discriminant should be equal to 0 or that we have equal roots. So in order to investigate this, the first thing we're going to do is we're going to substitute y equals 5x minus 2 into y equals 2x squared plus x. So we're going to replace the y there on the left hand side with 5x minus 2. Now, we will need to rearrange this and equate it to 0. Before I do that, I'm going to flip it all around so that I have my 2x squared plus x on the left hand side, and on the right hand side I'll have my 5x minus 2. From there, I'm going to bring my 5x over to the left and subtract it, so that I'll have 2x squared minus 4x, and the negative 2 will come over and we will add 2, and this is now equal to 0. The next step is we'll take out a common factor of 2, and we're left with x squared minus 2x plus 1. Now this can be factorised to give x minus 1 equal to 0. Before we go any further though, we're going to have a little look at our discriminant. So here the values of a is 1, b is minus 2 and c is 1. So subbing that into our discriminant, we've got negative 2 squared, subtract 4 times 1 times 1. So 4 take away 4, which is 0. So since we have a repeated root, but also we have b squared minus 4ac equal to 0, the line is a tangent to the parabola at x equals 1. And we now need to find the coordinate of y. So to do that, we're going to sub x equals 1 into the equation of the straight line, which would be y equals 5 times 1 minus 2, which gives a y coordinate of 3. So the point of contact is 1, 3. Example 2. Find the equation of the tangent to y equals x squared plus 1 that has a gradient of 3. The equation of the tangent is of the form y equals mx plus c. If we have a gradient of 3, we can write this equation as y equals 3x plus c. The missing variable is our y-intercept. To find the value of our y-intercept, we must start by equating the tangent's equation with our parabola x squared plus 1. Use substitution to do this, and we get an answer of 3x plus c is equal to x squared plus 1. We will now rearrange this and equate it to 0. giving x squared minus 3x plus 1 minus c. As the line is a tangent, we can assume that our discriminant is equal to 0. So b squared minus 4ac equals 0. The values of a, b and c are a is 1, b is minus 3 and c is 1 minus c. Substituting these values in, we get negative 3 squared, subtract 4 times 1 times 1 minus c. This will simplify to give 9 minus 4 plus 4c equals 0. 4c is equal to negative 5, therefore c is negative 5 over 4. Therefore the equation of the tangent is y equals 3x minus 5 over 4. Alternatively, we can rearrange this to give 3x minus y minus 5 over 4 equals 0. Now try these examples on your own. Please pause the video. The answers. A, you should have got your discriminant equal to 0 and the point of contact was 2, 4. And B, again, discriminant is equal to 0 and the point of contact is negative 1, 4. If you would like some extra work to try, turn to page 161, exercise 8J, questions 1 and 2. What have we learned today? Today we've looked at the intersection of lines and parabolas. We must follow the steps, substitute the straight line equation into the curves equation. We must rearrange and equate to 0. We must then use the discriminant to find the number of points of intersection. And finally, if we are asked, we must find the coordinates of the point of intersection.